We're continuing on here with constant and varying rate of change using tables and graphs. And so here are the learning targets that we've already started to hit or that we're also going to hit here in this foldable. I can find the rate of change from tables or graphs. We did that on here. We found the rate of change by putting the amount of change in dollars over the amount of change in weeks. Or when we opened up, we did the amount of points that changed over the amount of games. I can determine if the rate of change is constant or varying, which again, we did that here. We did, does this represent constant or varying? This one was constant. This one was varying because it changed from time to time. I can understand that constant rate of change makes a straight line on a graph. We did that down here in our points to ponder. What does constant rate of change look like on a graph? It's linear, or it forms a line. And I understand that varying rate of change makes a nonlinear graph. So we talked about what does a varying rate of change look like on a graph? Well, it means it's a nonlinear function. So we're just going to kind of dive deeper in and do a couple more examples where we're looking at determining constant or varying rate of change. In this first set of tables, it says determine if the rate of change shown in each table is a constant or varying rate of change. Then determine if the relationship is proportional or not proportional. So when we do this, to find constant rate of change, we're going to find the change in x. In this case, it appears that each time we go from one box to the next, we're adding 1. Negative 3 plus 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And then our y values, this is 10 minus 3 is 7. 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is negative 2. And negative 2 minus 3 is negative 5. So in this value, we have a consistent change. We have a constant rate of change because every time x increases by 1, y decreases by 3. So this is definitely a constant rate of change. And here's where people get a little bit confused. They think, well, if it's constant, it's linear, so it's automatically proportional. However, that's really not the case. Because in this case, remember that proportional and not proportional. Proportional means it has to go through the origin. And at this point, when x is 0, y is not 0, but y is 1. So because this, even though this is a straight line, this table, if we were to put it on a graph, it does form a straight line because it has a constant rate of change. It is linear. It doesn't go through the origin, and so this is not proportional. In this next table, we're looking at how is x changing. And it appears that, again, we're adding 1. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So we're going up by 1 every time in our x values. Our y values, 4 minus 3 is 1. 1 minus 1 is 0. 0 plus 1 is 1. 1 plus 3 is 4. 4 plus 5 is 9. And so, is this a constant or varying rate of change? Well, this is definitely, we're changing different values every time, so this is a varying rate of change. And if it's varying, it's automatically not proportional, because if it's varying, it's nonlinear, and in order to be proportional, it has to be linear. So this table is showing a varying rate of change that is not proportional.